In this video, I'll be covering the base sketch of the whole climb. Here we go. So when counting a section like a climb, or really anything but the dry base, we first have to start with referring to the dry base. So now in reality, when I started counting the climb, it looked like this. This was the version of the dry base, and the climb was actually planned to go like somewhere on top of these two beams here, on top of the battery, which was actually kind of a bad idea. But again, we're only going to be counting the final version of the climb in this video and not going over all the changes in between. So I'm going instead to refer to this version of the drive base, which is much closer to the final version of the drive base. Okay. I mean, this robot was not planned out the best it could have been. We just happened to realize that we didn't need pneumatics anywhere on the robot. So originally, these pneumatics parts were here, right, taking up all this room. But then we realized we didn't need them, so we removed them, and this actually made for a much better place to mount the climb in this area. Usually you have to deal with changing your design to get everything to fit together properly in the master file once each person is finished their sub-assembly. But the amount you have to do that can be reduced by having a very well thought out plan your entire robot. This means creating as accurate as possible sketches of profiles of the robot from the top, side, and front during the planning phase. So yeah, try to do that. Anyways, now to the actual sketch. So, start a new file, and we're going to refer to the cube. This climb is actually going to go on the back of the robot, so we know back is here. There's the cube in the top right corner, right? And we are going to create a planning sketch on this plane. Okay, and we know back is that side. So, how it starts is we can do a center point rectangle representing the drive base. And we're also going to do this in sketch mode because right now we're just outlining the drive base, and we don't actually want any of the shapes we draw right now to be created into some kind of part in this file. Right, and so we know the 30-inch by, click tab to switch to the other input, 30-inch by 30-inch square, representing the square drive base. Okay, wow, okay. I'm saying should be in inches. So here we go. Right, so looking at the drive base, we can refer to this piece of stock here and this piece of stock here, and we know that the climb is going to have some beams going across underneath these two pieces, okay? And so we want to draw in both of those pieces of stock in the climb tutorial planning sketch, okay? So first we should also just take a measurement for reference. What is the distance between these two rectangles? 8 inches. Okay, so let's draw that in. On top here. Right. This is 1 inch wide. There's another one, 1 inch wide. Dimension between these two, which is going to be 8 inches. Okay. And so now we've got our two relevant pieces of stock drawn in the sketch. Here we have to plan out the rest of, well, we have to plan out like what the climb looks like from this perspective, at least where all the stock pieces are going. Right, so in this climb we have some kind of, piece going across. We also have two towers, and inside those towers we're going to have some kind of linear lift. And we're not going to draw this in this sketch, but eventually you'll have two sets of arms outside of the towers on either side. Right? So these pieces going across, now we want to switch to actually solid line mode. We don't want to be in construction mode anymore because the pieces we're going to draw in now are actually probably going to extrude from the sketch later to create some pieces of stock. All right, so this piece is going to be 10 inches. Well, that's a nice round number, as it should be, so mechanical can actually cut up this piece. And we're going to have this piece be a 1 by 1, yeah, a 1 by 1 there, another 1 by 1 there, supporting the two towers. Okay. We can create some kind of dimension, space this out. Either you could create a dimension there, or you could like draw some kind of center line, which actually might be better. That should be in construction mode. And I'll draw this across here. Okay, these should be in construction mode. And we can make these equal constraint. So when one is moved, the other will also get moved. Amusing. That's okay. I'm gonna just fix this up a bit. Extend this over here. Then midpoint this line there. This point here. Cool. So now that's more fixed. Okay. Now this dimension, I mean, it could be changed. I just know that from the final version, it actually used to be smaller, but from the final version, it had to be 9.75 inches, just given that we're gonna have some we're gonna have the arms here, and if they were any bit wider, if the climb was any wider, these arms would hit into the sort modules, and so that was a constraint in this area. And when I first CAD'd it, it actually was, a lot. The climb was actually a lot wider. Maybe this was 8 inches, and I realized that was going to be a problem, so I had to change the design while CADing it. Right. So I know that's 9.75. And now we are going to put in the towers and the linear lift. Okay, so this is going to be a 2 by 1 over here. This is going to be a 2 by 1 over here. Right. So right now they can move. We have to constrain them properly. And there's going to be this whole linear lift in the middle here. It's going to be 2 by some distance. And then on top of that, there is going to be more 2 by 1s. So this bottom rectangle here, I should draw it from other. Okay. This bottom rectangle here is representing the 2 by 1 going across, and these 2 by 1 inch rectangles are representing some pieces of stock that are going straight up here. Okay, so we got that all. Why does it keep doing that? Right, we've got this all dimensioned. Hold up, I'm gonna click finish sketch. Sketch done. There we go. Okay, now hopefully stop giving me trouble. So what I'm going to do is put in some collinear constraints to keep this all lined up. And then now I have to decide a dimension from this piece of stock here to the tower. And this is going to be 2 inches. Why? First, we want it to be, oh dear, so that's not coincident. Okay, so first we want this to be we want this to be a round number, so probably some increment of 0.25 inches, but preferably 0.5 inches. Okay, and we know a few things. Oh yeah, I forgot to clarify. One of the gearboxes, the gearbox for the linear lift, is actually going to go somewhere around this piece of stock here. You know, just making design choices. I figured this would be a good place to mount the gearbox too. You have to look at what's around. Like, can you mount something onto the drive base, or do you need to create a new piece of structure and mount it onto that? So in this case, I'm just making the gearbox go off of the structure that already exists in the drive base. And we did the gearbox calculation last video, so we know that this is going to be a two-stage gearbox. What my plan is to put a motor right here, right? One stage of gears on top of this piece of stock here. Another stage of gears here, okay? And another plate there, and then there has to be some kind of sprocket at the end of all of that to actually drive the chain that's going to be moving this lift. Okay, so if we refer to here, we know this gear is basically 0.5 inches wide. This sprocket is also basically, yeah, well, okay, not quite, but it's like very close to 0.5 inches wide, right? And we also know we're going to have a number of thick Delrin plates. One here, one here, one here, maybe possibly a third one, right? And so with all that in mind, we want this to be greater than 1 inch. Maybe it could have been 1.5, but it's better to be safe than sorry, and 2 inches works perfectly fine, so I went with 2 inches. Okay, now the next dimension to figure out is, can again do an equals kind of thing here. These two. Cool, so when I drag this, yeah. So now we want to figure out the dimension between these two pieces. Now the reality is it could be a very small distance. It could also be a decently wide distance. It doesn't really matter too much. I mean, you don't want it to be too wide because of how the bearings are going to be structured, but whatever distance you have here, I mean, there needs to be some distance, and it's going to be filled by bearings, so it creates a very smooth surface for the linear lift to move up and down along of. So I just decided to go 0.5 inches. It's nice. It's not constrained properly. There we go. Cool. Okay. And so that's basically that constrained. I mean, arguably that sketch line should be constrained there, so you know what, just like that. And we are nearly done with this. We need to do a few more things. So now we've got this rectangle here. We actually have to offset this shape, okay? And we want this, it depends on how thick your stock is. So in this case, our options I think are like usually either 1.5 or 2 mm. You have to check what we have, but in this case, because it's going to be part of a climb, right, and the whole weight of the robot's going to be on these pieces, I decided to use a thicker piece of stock. And so we ordered some 2.8 mm thickness stock for this part of the climb. Why is this in construction mode? I'm not doing a good job of representing this, but in general, you should be very aware of whether you're in construction mode or not, instead of whatever the hell I'm doing. But yeah. Okay, so then this is 2.8 mm. And we're gonna time. Cool. Okay, so the last point is you want to check over your file. Here's a perfect example where there's some blue left. That means something is not fully constrained, and so you need to go constrain it. I'll do that by clicking on this point right here, and then now everything's fully constrained, and that's where you want your file to be at. So for now, this is all we're going to do with the planning sketch. Maybe a bit more will be added on later once more of the robot is CADed.